This video is explaining how to solving radical equations. We're going to be solving multiple different types of radical equations. So I'm going to turn this so I can look at the problems. I'm going to zoom in on here. The steps to solve. Since we're going to be solving steps to solve, that means that we're actually going to do PEMDAS backwards, which is SADMEP. SADMEP. So we're going to add and subtract away first from the x, because we're solving for x. We're going to divide or multiply, then we look at our exponent, and then we look at the parentheses. Now, parentheses is also just a grouping symbol, and an exponent doesn't necessarily have to be an exponent. It can be a radical as well, because in a previous video, we converted radicals to exponents and exponents to radicals. So the first thing we want to do is to isolate the radical. That's our exponent part. Okay, so we have to add and subtract away, then multiply or divide. So our exponent part is our radical. Once we've isolated the radical, we're going to raise the entire equation to the power of the radical, so the index, or the reciprocal of the fraction exponent. So the reciprocal is when you flip the fraction. So reciprocal is when you flip the fraction. Because when you multiply by the reciprocal, it will end up turning into 1. Now, we're not multiplying, we're raising to the reciprocal. What that does is it gets the exponents to become a 1, which is what we want. Once we've done that, that'll get rid of the exponent or the radical, and then we're just left with a basic equation where we want to solve for the variable. And again, we go back to SADMEP. Once we have our answer or answers, we have to plug our answers back into the original problem to make sure they work. Now, the reason we have to do this is because with radicals, you can actually have what's called extraneous solutions. So we have to make sure they work because we might have what's called extraneous, E-X-T-R-A-N-E-O-U-S, extraneous solutions, E-X-T-R-A-N-E-O-U-S. Extraneous solutions. What extraneous solutions really are false solutions. That means that, if you did everything correctly, and that's if, because sometimes it might be extraneous because you didn't do the problem correctly, but if you did everything correctly, and when you plug it back in it doesn't work, that's considered an extraneous solution, and that can happen. Okay, so we actually do have to check, because if you don't check them and you say, yes, my extraneous solution works, that's not correct. Okay, so we're going to go to our first example. We have the square root of x plus 3 equals to 5. Now, I don't want to mess up my original, so I'm going to actually rewrite my problem so that I can work with it, because I always want to make sure I plug my answers back into my original so I can check for those extraneous solutions. So I don't want to mess this up. So I'm going to put the square root of x plus 3 equals to 5 underneath it so I can write it out. Now, I want to isolate my radical. So I'm going to highlight my radical or my fractional exponent, whatever is attached to, and then I'm going to get everything away from it. So that's my radical. Now, because nothing is attached to my highlighted part, that means I can go ahead, I've already isolated the radical. I can go to step 2, where I can raise the entire equation to the power of the radical or the reciprocal of the fraction exponent. Now, this is a radical, so I want to raise it to whatever the index is. Now, the index, since it's a square root, I'm going to raise it to the squared power. So I'm going to put it squared on both sides. Because when you square a square root, those are inverse operations of each other. That means that they will go away, just like adding and subtracting make each other go to nothing. So we'll be left with x plus 3 equals. We did not square root something, so I just do 5 squared is 25. We've done step 2. Now for step 3 is we solve for the variable. The variable is x, so I go back to SADMEP and I go all the way back to the beginning and do S and A, so add or subtract. I have to move that 3 to the other side, so I have to subtract that 3. And we end up getting x equals 25 minus 3 is 22. X equals 22. Now, I have to check this. So for the check, put a little check down here. I'm like, all right, let's check this. The square root of, I'm going to plug 22 back in here, 22 plus 3 is supposed to equal to 5. 22 plus 3 is 25. The square root of 25 is 5, so I put a check mark saying, yes, that works. I have to actually show my check, and you can do it in your calculator. The square root of 22 plus 3. The square root of 22 plus 3, close parentheses, is 5. And it does equal 5, so that means that it is correct. So I can say, yes, this is our correct answer. Example 2, I am again going to write down my original problem. So I'm going to have 3 square root of x. I'm going to make sure I don't extend my radical. Plus 3 equals 15. So I'm going to highlight my radical because that's what I want to isolate. The radical is specifically the square root of x. That's what I have to get alone first. So I have to do SADMAP. I have to add and subtract first. So I have 2 3's attached to it. I want to subtract the 3 first. So I subtract this 3 from both sides. And I have 3 square root of x equals 15 minus 3 is 12. Now, I still need to get my square root of x by itself. So the next step, we've added and subtracted. Now we have to multiply and divide. That 3 is multiplied to it, so I need to divide both sides by 3. So I end up getting the square root of x equals 12 divided by 3 is 4. Now, the square root of x is finally isolated. So now I can go to step 2. To raise the entire equation to the power of the radical or reciprocal of the fraction exponent. So this is a radical. So I do actually raise everything to the power of the index. The power of the index was 2, so I raised everything to the second power. And I end up getting x equals, so x will be alone, because when I take that out, I'm just left with x. X equals 16. But we have to check it. So I put my check down here. And I put 3 square root 16, and then plus 3 is supposed to equal to 15. So I check it in my calculator. 3 square root 16, close parentheses, plus 3, enter. It does, in fact, equal 15. So that means that this is checked. That's good. So we can circle our answer saying that is correct. So far we don't have any extraneous solutions, and that's okay. Right, example 3. Again, I'm going to write my original problem again. The square root of y minus 2, and then minus 1 is outside the radical, equals 5. I need to isolate my radical, so I'm going to highlight my radical and everything inside of it and get everything away from that. So the first step, SADMAP, so add and subtract, I'm going to add 1 to both sides. So I'm going to have the square root of y minus 2 equals, add 1 becomes 6. So again, I need to get my square root symbol isolated. It is isolated, so I can go to step 2 by raising it to the power of the index. So I'm going to, the index is 2, so I'm going to raise both sides to the second power. And we'll have y minus 2, because again, those are inverse operations. We're just left with y minus 2 equals 6 squared is 36. Now we go back to the SADMAP and we add and subtract away to get our variable. So we end up getting y equals, we're going to add 2 to the other side. We get y equals 38. So again, we have to do our check. So our check is square root 38 minus 2, and then minus 1 equals 5. So calculator, square root 38 minus 2, close parentheses, minus 1 does equal 5. And that is correct. So we put check mark and say yes, 38 is our correct answer. Example 4, we need to isolate our radical, but in this case we don't have a radical, but we do have a fractional exponent. And if you remember from previous notes, we have talked about that a fractional exponent can be turned into a radical. So I actually have to highlight the exponent and everything it's attached to. It's attached to the parentheses. So I'll highlight all that. So actually I want to rewrite this problem and re-highlight it. 3x plus 1 raised to the 1/3 plus 5 equals 0. So I'm going to highlight again the parentheses and the exponent it's attached to. So I need to isolate this first, so I need to subtract the 5 to the other side. I need to subtract the 5 to the other side. I'm going to write that. So parentheses 3x plus 1 raised to the 1/3 is equal to a negative 5. Then I'm going to, since I have the radical part isolated, that means I can get rid of the radical part. So step 2 is either raise it to the power of the radical or to the reciprocal of the fraction exponent. This is to the reciprocal this time. So that means I'm going to raise everything to the reciprocal of 1/3. The reciprocal of 1/3 is 3 over 1. 3 over 1. Or basically just cube it. Because this is technically a cube root, and if I cube it, it gets rid of them. So we're left with 3x plus 1 equals, and now parentheses, negative 5, close parentheses, negative 5, close parentheses, raised to the 3rd power, because 3 over 1 is just 3, is equal to a negative 125. So it's equal to a negative 125. And now we still got to solve for x, so we want to subtract the 1 to the other side. Subtract the 1, we end up having 3x equals negative 126, because negative 125 minus 1 is negative 126. And then we have to divide both sides by 3. So I'm just going to click divide by 3. And I get negative 42. So we end up getting x is equal to negative 42. But again, we have to check it. So I'm going to do my little check down here. So I do parentheses, 3 parentheses, because I'm plugging it in here and it's attached to something. Negative 42, close parentheses, plus 1, close parentheses, raised to the 1/3, and then plus 5. Should equal to 0. Now this is a little bit more complicated, so I'll show you in both the new and old calculator. Alright, new calculator, or sorry, old calculator. I have to be very careful about my numbers. Parentheses, 3, open parentheses, negative 42, close parentheses, plus 1, close parentheses. That's that first part. Raised to, that little caret key, raised to. Since it's a fraction, I have to put the fraction in parentheses. So parentheses, 1 divided by 3, close parentheses. And then I have to add 5. When I press enter, it should give me 0. It does. In the newer calculators, it's a little bit easier to do this. I have parentheses 3, parentheses, negative 42, close, plus 1, close, raised to, and since I already have it up in the exponent, I don't need parentheses around my fraction, but I do have to get out of my exponent and then press plus 5, and it also gives me 0. So both calculators give me a 0, so that's a check. That means that that negative 42 is a correct answer. Okay. I'm going to go to example 5 as well. Example 5. So I'm going to rewrite the problem. X plus 2 raised to the 2/3 equals 9. I'm going to highlight either the radical or the exponent. The 2/3 is our exponent, and it's attached to the parentheses. So everything in the parentheses gets highlighted with it. Now there's nothing on the left or the right of it, so that means I can go ahead and go to step 2. And that says to raise everything to the power of the radical or the reciprocal. So I have a fraction, so I'm going to raise it to the reciprocal. I'm going to raise both sides to the reciprocal of 2/3, which is 3 over 2. So 3 over 2. So on the left, I'm going to be left with x plus 2 equals. Now, because I'm dealing with the reciprocal, and I did it down here too, but I cubed it, which I didn't have a fraction any longer when I cubed it. That made things a little bit easier. But since I still have a fraction when I do the reciprocal, I have to be very, very careful about something. If, make a note, if your new denominator, so the reciprocal, if your new denominator is even, you're going to have two answers. That means we're going to have plus or minus. So if we do 9 raised to the 3 over 2, we're going to get 27, but it's technically plus or minus 27. So we put plus or minus 27 because the new denominator is even. If it's odd, you're only going to have the one answer. You're going to have whatever you get from it. But you only have to worry about that is if you have a fraction when you do the reciprocal and it's still a fraction. And then if your denominator is even. So we technically have x plus 2 equals 27 and x plus 2 equals negative 27. So we'll have two different answers. That means we have to check two different answers. So we subtract 22 from 27. 27 minus 2 is 25. And then we subtract 2 from negative 27. Negative 27 minus 2 is negative 29. So we have two answers. Means we got to check two answers. So check. We have 25 plus 2 raised to the 2/3. It's supposed to give us 9. So I do parentheses. 25 plus 2, close parentheses, raised to the originally 2/3. Supposed to give us, it's supposed to, oh, I'm sorry, plus 2. I put plus 9. Parentheses 25 plus 2, close parentheses, raised to the 2/3. It's supposed to give us 9, and it does. So we know that x equals 25 does work, so we can circle that. Now we do the same thing with the second one. We do our check. We do parentheses negative 29 plus 2 parentheses raised to the 2/3 is supposed to give us 9. So I put in parentheses negative 29 plus 2 close parentheses raised to the 2/3 is supposed to give us 9. It does. So that's a check as well. That means that x equals negative 29 also works. That means that it is not extraneous. Alright. So we have two answers because the new denominator was even. So if you have a fraction when you do the reciprocal, if your denominator is even, you're going to have a plus or minus that number. Example 6, again, I'm going to rewrite the original problem. 3 parentheses x plus 3 raised to the 3/4 equals 81. Again, I need to isolate the radical or the fractional exponent. The exponent is 3/4 and it's attached to the parentheses. So I only use the parentheses. That means that 3 is attached, so I need to get rid of that. I don't distribute. Again, we're trying to get rid of it by doing SADMET. So we're actually going to divide everything by 3. Now again, when you divide by 3, the 3 on the outside is what actually will divide. You can't touch the inside of the parentheses because it's inside the parentheses. So we have x plus 3 raised to the 3/4 equals 81 divided by 3 is 27. So again, I'm going to highlight my exponent and the parentheses set. There's nothing attached to it now, so now I can raise it to the reciprocal because it's a fraction. So raising it to the reciprocal, raise both sides to the reciprocal. 3/4 reciprocal of that is 4 over 3. Now again, I have a fraction, so I have to check. Is my denominator even? It is not even, so I'm only going to have one answer. So on the left-hand side, I'll have x plus 3 equals. I'm only going to get one answer from this, so I'm going to type it in. I'm going to do 27, parentheses, 27, close parentheses, raised to the, it was 4/3. I get 81. So I just have x plus 3 equals 81. Not plus or minus, just 81. Now I just need to subtract the 3 to finish solving it. So x equals 81 minus 3 is 78. So again, we're going to check it. So to check, we do 3 parentheses, 78 plus 3, close parentheses, raised to the 3/4 is supposed to give us 81. Okay, so calculator, 3 parentheses, 78 plus 3, close parentheses, raised to the 3 divided by 4 is supposed to give us 81, and it does, because that was from the original. Check. That means our answer is good. Those are the first 6 examples of how to solve using solving radical equations. We had no extraneous solutions on here, which is perfectly fine, but it is always imperative that you check your answers to make sure. And again, the one thing you have to remember is when you do the reciprocal, when you raise it to the reciprocal, it's not multiplying, it's raising it to the reciprocal. If you have an even denominator, you're going to have 2 answers.